All right, here we go. I think I begged yesterday. I'm going to beg again. You need to check these tonight on Aspen to see how you're doing and to bring any questions you have to class tomorrow. All right. Again, I am very nervous for some of you when we start these proofs because I know it hasn't gone great all year, and I don't know how it's going to go today or tomorrow. All right. We do have a quiz on Friday that covers all the parallelograms, and anybody remember what we did the first day? The interior and exterior angles of any polygon. All right, any polygon. Okay, so that's on Friday's quiz. Get in here if you need help. I don't know what to tell. I'm just warning people. That's the best I can do is warn you at the very beginning of the unit. What you do with that is up to you. All right, and hopefully by the end of today, you're going to be like, wow, this guy's no joke. Because we're going to use theorems from this unit, 2, 3, 4, and 5 as well. Those units. All right. All right, let's see what we got. Let's get after it. Before I go do a proof, I need the properties from you one more time. Properties of a parallelogram, because they will be used in the proofs we do today. 5 properties of a parallelogram. I'll write them off to the side here in white. All right, here we go. Start us off. Let's go quick so we can get to these bad boys. 20, first property you remember from yesterday. Opposite sides parallel, yep. Also, when you have a diagonal drawn in, look for what type of angles. Alternate interior, keep that in the back of your mind, even though that's not a property. All right, opposite sides parallel. Let's keep this train going. 15, what do you got for me? Also congruent, nice job. All right, next up. 8, what else you got for me? Garbage, not here. All right, let's go, 17. Yes, consecutive angles, supplementary. 2 more, 2 more. 20, another one. Opposite angles, congruent. And then the last one, don't forget about that, this one. 18, what's that last one? There you go, diagonals bisect each other. All right, here we go. I told you also, yep, never mind, it hasn't come up yet. Forget about anything. I've told you these 2 quadrilaterals are parallelograms. Somehow get me segment WX congruent to segment ZY, somehow. All right, what I'm going to do, what I like to do is anytime they tell me there's a parallelogram involved, I like to highlight it. So that tells me use any of those 5 properties on that figure and this one as well. So everyone sees segment WX and ZY. Got to get them congruent. And we're not proving triangles here. There's no triangles to prove congruent, unfortunately. Okay, what are WX and ZY in the parallelograms? Angles or sides? Okay, so we should be using some theorems about sides. Some properties about sides. Are they equal to each other right now? No, because they're in 2 different parallelograms. But let's see if you guys can get me anything here. I don't want to hold your hand and just tell you, write this down, write this down. Do we see anything, any properties we can use here? I'm trying to get WX and YZ equal. Anthony, start us off, sir. Okay, that is a correct fact. VT is congruent to XY. So VT, XY, ZY. You probably said that, I just didn't. ZY. There you go. Why is that true? Now I'm going to turn it over to you. Why did Anthony just give us something that was true there? What did he use? 7. What do we use? Okay, what did I write first? What did I have you guys write yesterday? Parallelogram implies opposite sides congruent. Got it. We're getting there. We're getting there, right? We're getting there. I got VT and ZY. Can anybody try to involve WX now for me? WX, Emma, go. WX is congruent to VT. And everyone, why am I going to just write this in the same statement? Same reason. If you want to write into a separate statement and reason, feel free. Look at what you just wrote. You have VT equal to ZY and you have WX equal to VT. This is nothing new. This is review again. Got it, Thomas? Do I need to say that? You can write that if you want. I don't know where you're going with that, though. You can write that. That's fine. But we're not proving triangles congruent. All right, there's no triangles. I'm asking you guys to look at these two statements we just wrote down and apply something we have used in the past, way in the past, probably Unit 2, when I used to have the yellow and pink cards up here. What do you got, Avery? WX is congruent to ZY because of substitution. Everyone see the substitution being used? We're right there. That was a one just to get your feet wet. You haven't sniffed anything yet. Ask now. Going. Get used to that sound, some of you. Moving on. Too harsh? Sorry. Too harsh? Some of you getting nervous right now? You can run out of the room if you need to. All right. Here's the symbol now. See that symbol next to ABCD? That's parallelogram. You're never allowed to use that. Sorry. I allow you to abbreviate it anyway, so be happy with that. All right. But if you see that symbol, that is saying that ABCD, the entire quadrilateral there is a parallel. Well, not the entire one. This part here is a parallelogram. So any of those properties can be used on that. And I'm also told that DF is congruent to EB. So all the way over here, congruent to all the way over here. And I got some straight lines that may help us out. Prove the two triangles congruent. All right, we need a review of this first. How many ways were there to prove triangles congruent? How many? 5. All right, let's go. We need a refresher here. 2, one way. Side angle side. Next. 26. Angle side angle. Did you get a fresh cut there, Jack? Nice. Professional or homegrown? Professional. You like it? How much say do you get in it? 100% say. Wow. Same blade all the way around? Or shorter on the sides? I can't tell. What blade number you tell them? That's not it. That's a 3 on the sides? On top? Whew, I think it's a little, all right. Okay, I thought 2. That looks like almost like a 1 or a 0 on the sides. All right, anyway, sorry about that. I'm just interested. What's going on? 28. Okay, I'll do it. Side, side, side. Ha! I'll take the easier one. Next up, 11. What am I missing here? Oh, nice. Usually that's the forgotten one, HL. And then the other one remaining here, 19. What do you have? Angle, angle, side. Got it. All right, so we're going to use one of these methods at the end, but you got to get me those pieces first. Got to get me angles and sides. And according to my givens, I did not give you anything. You do not have any sides or angles in those two triangles. So you're going to use your parallelogram properties. Any theorems from the past we're going to have to use here. All right, so let me open it up to you guys. Can you get me any sides or angles based on either properties or I like to call old school theorems? Julia, where are you going to start? F is congruent to E. That is not true. That's not the parallelogram. I don't like C congruent to A either because there's multiple angle C's in that diagram. You got one more shot here for me. You are at the right angles, but you didn't call them the right things. So you're talking those two. Everyone agree? That is true. And now some of you may say, they're not even in the triangles yet. All right, just hold your horses. All right, we're going to get there. All right, we're going to get there. So angle DCB is congruent to angle DAB. I need a good reason, though, why she said that. 5, why is that true? I got a 5 in the house. Here we go. Why are those two angles congruent? And because it was given, it was a, what was this figure to begin with? So I need to write parallelogram implies opposite angles congruent. We're going to use that. Don't worry. Some of you may see how we're going to use it, and some of you may be like, I have no idea what's about to happen here. All right, so I still don't have sides or angles. Emma, you going to get us something here? Oh, there we go. I got a pair of sides there, huh? DA congruent to CB. Nice job, young one. Why is that fact true? Getting everything I can out of you. 16. Why is DA congruent to CB? Thomas, why are those two sides congruent? DA and CB parallel implies opposite sides congruent. And you guys might remember back in this unit, I'm going to do the same thing. All right, you got a pair of sides for me. Need more. That's not, this one lonely thing here is not going to cut it. One pair of sides. Hi, Emma. DC congruent to AB. I'm going to put it right here in the same statement here. DC and AB, those are opposite sides. Are those sides in the triangle? No, but let's go here. Here's where it gets tough. You got to dig deep here. How is that going to lead me to a side in these two triangles? Let's go, Sam. Darn it, subtraction. I got to take these full sides and subtract the ones that were just given to me. Everyone see the subtraction going on? So I'm going to say EB. Tell me what we're subtracting here. EB minus AB is equal to DF minus DC. Subtraction. And this is not going to change. What do we always put after subtraction? Substitution. To say which sides? Which sides are in my substitution step? Number 17. Which sides by my substitution step are congruent? CF and EA. And that gives you a pair of sides. Yes, question, Mason. All right, not yet. I don't want her to do the big reveal yet. Start thinking about this. What do you have right now? Two pairs of sides. Guys, hey, there's only two options. It's either going to be side angle side or side side side. Okay, you either get me the third pair congruent of sides or this angle in between. And remember I said Julia at the beginning gave us those opposite angles. We still haven't used them yet, and they're about to come into play. And this is why it's so darn tough, I know, for some of you guys. How can you use these angles to get to those? So I could say side angle side. Used to be up here in pink, I believe. All right, how can I use these two opposite angles to get to these? That's going to be the tough part here. We got it. Dylan, you've been having your hand raised. Let's go. These are supplementary angles. They're right next to each other, correct? These are supplementary angles. They're right next to each other. Great job, but I can't write that in right now. The next step is not supplements of congruent angles. Does anybody remember the requirement you needed to write in before you were allowed to use that one? You need to tell me what pairs are supplementary. So this angle and this angle are supplementary. This angle and this angle are supplementary. You got to tell me the pairs that are supplementary before you use the theorem Dylan just gave us. All right, so we got some work cut out here for us now. So angle I can't even read any of them anymore. Name, you guys don't have to wait for me. Name the pairs of supplementary angles. Tell me they're supplementary. Just got to get out my cheat sheet. So angle DAB and angle DAE are supplementary. Angle BCD and angle BCF are supplementary. Not because supplements of congruent angles are congruent. How do I know those are supplementary? It used to be a theorem there. Linear pairs are supplementary, yes. Now, after you tell me which pairs are congruent, yes, now you can tell me those angles in the triangles. Angle DAE, congruent to angle BCF. Supplements, yep, of congruent angles are congruent. And that gives me my pair of angles. Everyone agreed? And now by what method are those triangles congruent? Side, angle, side. Wow. We all right? How do we feel here? We brought back subtraction and we brought back supplements of congruent angles are congruent. And we're about to bring back a little bit more. Go ahead, Thomas. 6, linear pairs are supplementary. Anytime you're going to tell me angles are supplementary, your reason most likely will be linear pairs are supplementary. Okay? Take a breather if you need to here. Everyone all right? Not too bad? Any questions you want to ask? So we are bringing back some old material. Okay, next up. Another proving triangles congruent proof. All right, so look, given I gave you ABCD as a parallelogram. So any property you want to apply to that figure highlighted, you can. My next question to somebody, what are these symbols and what should I put on my diagram that represent them? What are these symbols here and what can I put on my diagram? 26, what are those symbols? And how can I represent them by putting what on my diagram there? Right angles, yes. Specifically at angle F and angle BEC. Got it. And everyone sees the triangles I'm asking you to prove congruent. So I already gave you what? A pair of angles. We just got to say, what do we need to say in the proof now? Say they're right angles. So here you go. There's my first step here. Angle F and angle BEC are right angles. Anybody remember the reason? Review, review, review. 8, and remember? Oh, garbage. 4. Well, why did I put them on there to begin with? What told me to put right angle symbols on there? There we go. After you tell me they're right angles, you should probably tell me what about them? 24? Darn right. Angle F and BEC are congruent. All right angles congruent. And that gives me a pair of angles right now. I think you guys should be able to get me something else. You should be able to get me another pair of sides or angles. Should be at that part. Should be there. Should be there. Should be able to get me another pair of sides or angles pretty quickly. Claudia, what do you got back there? She is correct. DA and CB are equal, everybody. DA congruent to CB. That's a pair of sides. Why is she correct, though? What's she applying? 24 again. What's she using? Perfect. Parallelogram implies opposite sides congruent. And now here's where we're going to struggle a little bit finding the third and final piece, unfortunately. But I'll let you look it over. We got time. I'll let you look it over right now, maybe discuss anything in your group. Where can you get another pair of sides or angles from? All right, this is really deep here, all right? You can talk about it if you want. Okay. Where else can you get another pair of sides or angles? Tough. It's got to be in the triangle. Triangle. Things, a lot of good things.
But this angle right here is supplemental. And then
Be a little tough. A lot of good things going on. A lot of good things, and they're probably correct. I think you guys are like me. I want to get there and do this the shortest way possible. All right, because I hear a lot of people saying alternate interior angles, supplementary, a lot of substitutions going on. You're probably all correct. All right, here's where I'm going to go. I'm going to go real deep on you. Property. Number 17. Not only are those sides congruent, they're also what? No. I'm just talking the sides. These sides are not only congruent, but what other property do they have? They're parallel. Everyone agree that they're parallel. Watch and learn here, kids. I probably didn't want to use that one. That mixes with it. Okay, how about this? Those are parallel, correct. Everyone are good with me so far. All right, and they are cut by that transversal. Everyone see this angle in the triangle right here? And everyone see this angle in the triangle right here? Anybody remember what we called those angles back in Unit 4? These were corresponding. And if you had parallel lines, what'd you know about them? Were they supplementary or congruent? Congruent. Okay, so these are corresponding angles right here. Now, can I say they're congruent right now in step 4? I still need to tell you what? Lines are parallel, so I still need to tell you that AD is parallel to, was that CB? Parallelogram implies opposite sides parallel. Now you can tell me the corresponding angles are congruent. So angle FDA is congruent to angle C. All right, I'm going to let you guys write this reason here for me. It's a review reason. What would I write for those two? We know what they're called, but how did I put it all together in that unit to say they were congruent? Christian? Perfect. Parallel lines imply corresponding angles congruent. And that gives me a pair of angles. So my final question of the day to somebody is, what's the method? Angle side angle or angle side? That's going to be my final question to somebody. Is that side in the middle of the two angles or not? So look at one of the triangles now, everyone. Look at one of the triangles and say to yourself, is that side we prove congruent in the middle of the two angles we have? 22, what's the method? Okay, I'm debating between angle side angle and angle side. because this side, everybody, is not in between those two. So I need to go with angle, angle, side. Questions at all? Gotta look them over. Gotta look them over on Aspen, please. All right, let's go. Get going. And at least I'm here for the next 10 minutes, so you can ask me questions if you get stuck. Talk it over with people in your group. Yes, change the homework to pages 10 to 11. Page 12 starts the notes for tomorrow, and I don't need you doing that. All right, pages 10 to 11 tonight. So the next 2 pages in your notes. All right, next 2 pages in your packet.